Well, well, well. Ladies and gentlemen, we are back. Finally back with the LinkedIn Learning C Sharp Coding Challenge. Um, One of the main reasons uh, that we took so long to get back, and you're probably wondering why you can't see my face, and we will get to that. But um, I'm going to try to start making my videos more intentional, less long, and just jam pack them with information. So this video is probably going to be like 30 minutes max, but it's going to be absolutely jam packed with information. With that being said, I am the Kodiak Killer, um, which is why I have to start making my videos like this. I can't be exposing my face to the general public. You gotta stay hidden. I'm just kidding. Here's my face. If you really wanted to see it. All right. You still probably could not seen it that well, but let's get after it. This problem was my first hard, and I ran into some fatto trouble, but I learned a S ton, and if you don't know what a S ton is, S is the first letter of a very bad word. So we will get to it. All right. So for this LinkedIn Learning Challenge, we created what is called an indexer. So this was my very first time creating an indexer, and I've never heard of indexers before. But basically, we'll go like this. In more complex applications, there may be times when you have classes that only store and retrieve values from a collection property. Lists, dictionaries, any collections, stacks, queues. The collection is a part of that class. The class is a collection. In our case, dictionary, as you will see. Okay, consider, these are the instructions for the video. Consider a retail store that uses a shop class with a collection of dictionary to keep track of inventory items. So that is our indexer. The shop class and the dictionary within is our indexer. Instead of having to call shop.inventory, and inventory would be the name of our dictionary, uh, to get or set the items you want, wouldn't it be nice to have direct access to the collection or item, in this case, the dictionary? I guess. I don't know. Would it be nice? I mean, I guess. I don't know. But that's what Harrison Ferrone claims. He thinks this would be nice, so and he's better at coding than I am, so we're going to go with that. All right, so what we need to do here, um, and trust me, if you're still watching, stay tuned. This is absolutely jam-packed with information, and it's going to be at a high level, so you're going to be able to understand it if you're an entry-level developer. Stay with it. Stay with this video. I'm telling you, it's good. All right, so the directions were add an indexer to an existing class to access its dictionary property directly. So instead of, like we said, instead of calling shop, which was our class that we made, and then inventory, which would have been our dictionary, then we could just add an indexer, as you're about to see how to create an indexer, to an existing class to access its dictionary property. The indexer should take in an integer value as a dictionary key. If you're familiar with dictionaries, they take in key value pairs. So we're storing the item. So for example, you have in so let's say three typical grocery items. You have bananas, oatmeal, and milk. So in the dictionary, bananas would be a value, and the key associated with the value could be 1. Then we go to key 2, we could have milk. Then we go to key 3, we could have oatmeal. So we take an integer value as a dictionary key. The indexer should return the dictionary value as a string. Bananas, milk, oatmeal. Those are our 3 strings. Alright, so we are responsible for throwing an error whenever, if we try to access an item in the inventory that doesn't exist or hasn't been assigned. So basically there's no key. It can get more complex than this, where we start looking at there's no value, but for right now, for these purposes, we're going to throw an error, and we're going to see how Harrison Ferrone does it as well. But if we try to access an item that doesn't exist or it hasn't been assigned, no key, meaning no key, then we're going to throw an error. If the user tries to add a duplicate item, same grocery item, we have to handle that as well. And as you'll see, we're not going to get into it just yet, but we can handle that right here. Typically, you'll see properties, at least from when I've done it, you can just set properties like, so you set your fields and then your property. So a property, for example, could be public string name get set. So IntelliSense just allows you to type get set, but in a real application, there's so much more we need to account for. It's not as easy as just getting and setting. There needs to be constraints on when we're getting the value, when we want to retrieve the value of an object's name, and then if we're setting, there needs to be constraints. In our case, if we're setting a new grocery item, well, we want to make sure that it's not already in there, like a real application. So we need more than just the get and set in the name property here. So that is where we can come down here and really start to customize the get and set accessors. Alright, so we'll go back. So we understand what we're doing. Again, we're throwing an error if we try to access an item that doesn't exist or it hasn't been assigned yet. If the user tries to add a duplicate item, we also throw an error. Alright, let's get rid of this. So, first I was like, okay, let's create our dictionary inventory. Right, we're gonna have to create a new dictionary, right? If we're gonna insert the items. And then I said inventory 1. So there's 2 different ways you can add a key value pair in a dictionary. We could have done something like it's commented out, right? The dictionary is commented out, but we could have done something like see, it's not letting me do it. Let's get rid of that comment, and then we'll go down here and say inventory dot add, and then we can go like adding our key value pair, so like 1 and then milk. So we could do it like that, or we could do it like that, where the adding is just we just add it right there as we're defining the value. So it's basically just given. So first I was like that. Well, to create an inventory, well, we need to make an inventory dictionary and then add values and then if we wanted to see our values, then we would go. If we wanted to see the grocery items in our inventory dictionary, well, of course, we would iterate over the dictionary using a for loop. Um, but then I was like, hold up, we don't need to declare and instantiate a new dictionary. That's what the indexer is for. This is our dictionary. By creating our indexer and our shop class, we have our dictionary. So we already have our dictionary. And me doing this came after I created my shop class. We'll get to the shop class here in a second. But we don't need to do that. We already have our indexer, which is a collection of type dictionary, and our shop class. So my first inclination was, all right, and this code is the correct code. But after I was wrong the first time, then I was like, okay, let's try initializing the shop class into an object. Okay, we did that, so that was right. But and then we're adding Larabars. If you haven't had Larabars, you got to go check those things out. Uh, we're only eating organic ground beef. Um, if they got 90%, 10%, 10% fat in there, we're getting that. 85% fat, we're gonna get that organic ground beef. And we got to go to Kroger to get that. Of course, we got to get the banana peppers and always room for some extra Larabars. The chocolate chip raspberries are hitting different. We added, so we could have done that. And then we could have iterated over this. But then how do we determine, okay, so this would have went through. But in our application, we don't want duplicate Larabars. We don't want duplicate Larabars. As a shop, so as a grocery store as a whole, not as a customer. Of course, as a customer, we want multiple Larabars because those things are absolute gas. But in the inventory, I mean, obviously you have blueberry Larabars, lemon drop Larabars, orange sherbet Larabars, but just let's just pretend there's one type of Larabars. This would have allowed us to put it in our dictionary, okay? But we don't want multiple Larabars, so this isn't gonna work. So then, where's then I was like three. I think we deleted it. Oh no, no, no. Okay. Then okay, then I was like three would be somewhere in here. And we have a then I was like four. Um, but we'll do three. So then I was like, okay, well we can use our. I actually was curious. I didn't know because this is my first time working with indexers and setting constraints and conditional statements within the. I think I've seen it before, but haven't really coded an actual application where we're setting conditional statements within the get and set to determine what values we're able to get out and what values we're able to set, in this case, in the inventory. So I will cut to the chase. We got about 15 minutes left here, so stick with it. It's a lot of stuff. It's actually really not, but just stick with it. There's some cool stuff that I found out. If you're an entry level developer, you are going to want to stay. And if you're not familiar with debugging, then you're going to want to stay. If you're an expert, then go code the next Facebook. All right, so we created our class shop. Then we created our indexer. So dictionary. So here we have created our indexer. Excuse me. Here we have created. Actually, you know what? I don't even know. All I know is we're creating an indexer in here. Where in, let's ask, officially, where in this code can we say definitively that this is where our indexer was created? Is defined. So I'm guessing it's just going to tell us that the whole thing is an indexer. Alright, 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 here we go. The line public string this integer index defines the indexer. Alright, perfect. Alright, yeah, so that's right. The this keyword is used to define the indexer. And index specifies that the indexer takes in an integer parameter. Alright, perfect. Okay. So this is where, so we've created our dictionary. We've created a field called item, which is a type dictionary. Then in our shop constructor, every time, every time we create a new instance of this shop class, it's going to come with items, which is a dictionary with key value pairs of integer string. Alright, and then here's where we get to the juicy part. This is where we create our indexer. This is where we define our getting set accessors. And finally, this is where we write our code. So I'm not gonna mull over all of this, but basically what we did, I still don't understand what this is for. I guess basically it just allows you to easily iterate over the dictionary, but I'm still learning about IEnumerables and interfaces. I know what they are, just haven't used them a ton. Regardless, so we check here for public bool duplicate items. So we want to check if there's duplicate items, right? That was one of the first constraints. If there's a duplicate item, then we throw an error. All right. So that will take in a string value. All right. So, but in order to get the value of a dictionary key value pair, you need the key. But in this case, we just pass in items index. So that's how you get the value. Where does index come from? Okay, so our keys are going to be integers, and we're just calling our keys index. So we say if duplicate items, so remember duplicate items passes in a string, and remember that our dictionary value is a string. And we say for each variable kvp and items.value. So now we're just iterating over the items dictionary and the value. So we say if kvp equals value and then string comparison dot ordinal ignore case, The naming convention is messed up. Um, it's a lot of mumbo jumbo, but basically this is just comparing the two strings KBP value on the value that we pass. It's comparing these two strings and basically saying uh, if they have the same characters but their casing is different. So like if Apple was the value and one of if value if Apple value was all uppercase and then KBP had Apple as well, but it was all lowercase. Basically, what this is doing is ignoring the case and just checking for the character. So if they do equal, if as we're iterating through, if we find a variable which is a value in our dictionary values that is equal to the value we pass in, then we're going to have to throw an error because, well, the item is already there. The item has already been inserted. And if it hasn't been inserted, then we can go ahead and add the value. All right? And then if we want to get the item, then we say if items, which is our dictionary, contains key index, so that'll be whatever the integer value is. So if it does contain our index, then we will return items of index. And this is our key. Items is our dictionary. This together returns our value. So we will be getting our value back. We will be returning or getting our value back. Else, if items does not contain key, then if it doesn't contain the key that we're trying to get the value from, then what do we know? Well, it's not there. And if it's not there, then guess what? We have to throw a new key not found exception. This item has not been added or assigned yet. Please add it to the dictionary. Alright. So then, after we did all that, then we go back over to the program. And then really quickly, because we don't have much time, so we instantiate our shop class, grocery, which automatically, as we know, has a dictionary. Upon instantiation per the constructor. Console.writeline, welcome to John's Grocery. Press 1 to enter a new item. Press 2 to exit. Then we read. If they press 1, we give them an option to decide what to do, either enter or exit. And we're treating 1 and 2 as strings, so just go with the flow here. We're just going to ignore that for now. And then I actually, at the start, so I was running into an infinite loop. And I couldn't really diagnose exactly why. But honestly, I still don't know exactly why. But I tried to debug it, and I'll just say this. So let me just add a breakpoint. Let me just add a breakpoint right here, just to show you what I found, or just some cool things. So many times when we are, so I'm not going to step through or anything, but look at this. So you want to check out autos, locals, watch one. So our autos is going to be like what is .NET automatically think is relevant to what we're doing. Locals is the variables that are local within our method, and then watch one we can basically manipulate whatever we want to see. All right, so then obviously we have our call stack, and then I've always seen this, but never really. I mean, I know that CPU is memory, but as just pretend like we're in the console. Um, I'm not going to replicate it because we don't have that much time, but just pretend it was iterating over itself thousands, just over and over again, an infinite loop, which is not what we want ever. So, but how do we diagnose that? One of the ways is like you will see all these options, they will disappear, they go away. You can't step in, it's just constantly running. All you'll see is this red. You won't be able to continue because it's going through a loop. All you'll see is the red and you'll just have to end the program. But an alternative approach here is to, and this is my favorite part that I learned, we can use our diagnostic tools to see our performance of our application. You're thinking, duh, but I mean, this is kind of cool. So in Visual Studio, it will literally show you how much work the CPU is doing. So if we're going through a while loop, then the amount of processing that our CPU is doing is going to be increasingly elevated. Look at my mouse. It's not shown here, but it will go high, and then it'll flatline. It'll just keep going because it's an infinite while loop. So look at our CPU, and another pretty cool thing about being able to look at the CPU and the diagnostic tools is we can see different parts of our code when our application is running where um, our code is inefficient. And if you know anything about Moore's Law, then you know that our ability to make increasingly more and more powerful hardware CPUs is becoming harder because um, just if you know anything about chip fabrication and stuff like that, right now we're at like the maximum. I think it was developed by IBM is like 2 nm node, which is insane. And I'm not gonna go off on a tangent here. Um, but basically, efficient code is gonna be extremely vital. Like we're gonna have to like stop relying on our processors to just brute force stuff for us. And as developers, we're really going to have to look at places in our application where we're running efficient code and where we're not. CPU and the diagnostic tools is a great way to look at this. When it spikes up to near 100, then we know that, okay, something in our application is causing our processor to work really hard. How can we go back and make our code more efficient? So that was pretty cool. Um, so I will go ahead, and of course we have our while loop. While user input doesn't equal 2, um, I'm not going to, honestly, I'll save you the time because I've been working on this for a couple of days and run into some problems. But that about the CPU is really what I wanted to share. Wanted to kind of give you an introduction into indexers. Um, I still really, there may be some value that I'm just not seeing with indexers in like a real application yet. Um, Harrison Ferrone thinks there is. Um, let's see. You don't really need to know all this. We will If you want to like pause the video and look at my code, you're more than welcome to. In the shop inventory class, you're more than welcome to pause the video and look at my code, but we will go ahead and run the application. So we're going to enter one item name. You know what we're entering. Come on now. You know what it is. Lar bars. Lemon. Uh-oh. What happened? Alright. So this is a problem that I was running into. So basically what we're doing here is we are trying to set or add an item before we're checking if we have the capacity to even add that item, namely, does the key exist in our dictionary to add the item? So they'll be mad at me, but I did ask ChatGPT for this. So what we have to do is check, like I just said, if the key already exists or not. So we check if the key exists, check if the value already exists. If the key or value don't already exist, then we go ahead and add it, add the value to that particular index that we're on. So I will use this. And honestly, I'm just kind of ready to move on to the next problem because this was indeed a hard. This was a hard problem. And I mean, I understand all of it. It's just going through the debugger and stuff. Take my breakpoint off. Stop. So we'll go 1, and this video is about over. So after we fill this out, we're gonna go with organic ground beef. We don't mess with the 75-25 lean fat percentage. Just so you're aware. Organic beef. Item added. Press 1 to enter a new item. Press 2 to exit. We'll go ahead and exit. Okay. So at this point, I'm pretty annoyed with this application, but I'm not gonna bore you all. See, timer is up. Timer, that means I'm boring you guys. So, hope you learned something about indexers. Obviously, my application still has a S time. By now, you should know what S means, an S time of problems. And I'm gonna go back through and fix those, but hopefully you have a pretty good idea of indexers, what you can do with indexers, um, and maybe that'll give you a baseline for further research. And then most importantly, when we're debugging, it's important to use our diagnostic tools and look at the CPU for instances where our code is just not efficient. So, hope you enjoyed. I'm out of here until next time. We're going to be coming back with a continuously increasing load of more concise videos. I hope I gave you a bang for your buck. I will shut up. I am out of here. You guys take care. Deuces.